This week's episodes were brought to you by the generous support of Yukofin. So that was already foobarred from before. Hey, there we go. Hey! Now we have 2 continents. Hey! Ooh, look how sexy these look! Oh, that's hot. That is some sexy continent porn right here, guys. Oh. Okay. Sorry. Got a little excited. Alright, let's add some noise. I think these continents look good before. Whoa, baby. Hold on to your shorts. So, what we're going to do here is we're going to loop through our whole map again. That's going to be fine. Hopefully I don't, fuck up the columns and rows again. I'm sure I won't. It's going to be fine. So what we want to do for each one of these is we want to get hex h equals get hex at column row like this. H dot elevation. Oh my god, you bastard. Elevation is going to be added to per-line noise. So per-line noise is a system for generating sort of quasi-random, well, it's not actually random, but it sort of looks at just noise. You know, you get those sort of cloud patterns. Like a good example is like, it's something like in Photoshop. If you were to just do something like render clouds. Okay, I probably should have done black and white, but that's okay. Something like this. You got a pattern that's kind of like this. You get, darker areas, lighter areas. And the per-line noise function actually returns values from +1 to -1 in this kind of system. The thing with per-line noise is that it's not actually random, in that it's reproducible. So if you ask for the noise value at a particular coordinate, and then 5 minutes later you ask for the noise value at the same coordinates, you get exactly the same value. It also tends to do this nice sort of smoothie kind of curve thing. Now, a full per-line noise function that you would sort of write on your own would give you different options for sort of seeding and doing different things like that, and tuning the number of chords and whatever. Unity does provide one built in. It's very, very simplistic in that it only asks for an x and y coordinate, which is not necessarily the ideal. The other thing you need to know is that it repeats from 0 to 1. So if you ask for if you put in x like 0.5 comma 0.5, right? If we do this, 0.5f, 0.5f. We ask for the noise here, it's going to give us a value, 0.78, some value. And then if we ask for the same thing at value of 1.5 and 1.5, we'll get exactly the same number. And, 1,000.5 and 1,000.5, we get exactly the same number. So it repeats on every whole integer. Whereas there's different options for that. But what you can do is you can do some math. So you want a number effectively that goes from 0 to 1. And then you can also do some further scaling. So let's assume, for example, and there's no reason we have to link this with our physical x and y coordinates in our world at all. At all, there's no reason to do anything like that. Although probably we will. So let's assume we want to do something like column divided by num columns. So now we have a value from 0 to 1, and rows, row divided by num rows. But often you don't want to use this as is. You probably want to throw in an extra division in there, because this lets you tune the resolution of your height map. You can use this division as a bit of a seed as well, so that you can tune different areas. There's also different things. We'll try the base value first. Here, tell you what, just for whatever, I'm going to leave in the 1 in there, because we can tune it or put it as a variable. Float noise resolution. We're going to start at a 1, and then we can fiddle around with that. And then there's offset things and various whatevers we can do as well. But yeah, we're going to get some value. What we might want to do is float noise scale. Because, so let's multiply this. Because per-line noise will return a value from -1 to +1. I think it might be 0 to 1 in Unity, but it should be -1 to +1. We don't want to change things quite that drastically. Let's run this for now and see what happens. Always good, but almost certainly we're going to want to scale that effect way, way down. Because now we should get absolutely nothing. Remember whole numbers. Oh, these are all integers. So the division's always coming out at 0. Thank you. We need to force this to be a float. Because this is always going to resolve to 0 or 1, which comes out to exactly the same. Let's try this one more time. Oh, there we go. Although, there's no way to tell. I don't think you can seed random, can you? Ah, there you go. We're going to seed the random generator with 0 over here so that it always generates the same continents. So if we hit play, we should get exactly the same thing every time now. And we do. By the way, that's how you can share map seeds with that. This is actually not terrible. But let me go and cancel this step here. So we're going to see the before and after the noise. Yeah, okay. So the noise is working, but sort of one giant clumpy area over here. So that's where you start like tuning some of the resolution here. Or the other way around. What do I want to do? Let me think about this. Double check what values these come up with. Ah, okay. Perline noise returns value from 0 to +1. That makes a bit of a difference. So, because we want things to go up and down, so we actually have to. Let me move the noise scale down to here. We need to subtract, say, 0.5f. There we go. So now it's going to be from -0.5 to +0.5. That's one thing. Okay. What I'm going to do is I'm going to remove this elevate code completely. I'm going to set it to the Perlin noise value now. So we should start to see a little bit more. We're actually going to get some repetition if I do it this way, aren't we? There we go. There we go. That's the sort of thing we want. Plus equals. Let's get this back in here. And then we'll have to bring down the scale because it's a little too strong. So again, right now, our basic continents without any noise looks like this. And if we throw this in, I should have a button so we can see before and after. I don't want the noise to be quite this dominant. Ah. See, these little islands are places where the noise peaks up. But only where it gets quite high does it actually show up, because it's got to compensate. So right now we do have the times 2. So now, because we've got the end result now is that our per-line noise function is adding or subtracting 1 from -1 to +1, because it's this bit here ranges from -0.5 to +0.5. We're multiplying the whole thing by 2. The places where they come up and poke up over 0, we get little islands, but it also adds a little bit of noise to our continents. We didn't have a lake here before. Our continent shape wasn't exactly like this. We get this nice... You no longer tell that what we're doing is dropping hexes, right? We were dropping... These continents were very much like just big hex shapes. But now they get a little broken up. Now they look pretty good. So let's go and remove the seed function. We should probably also have a bit of an offset. Vector2 noise offset to randomize it, because otherwise we'll always use the same per line noise, because per line noise is not random. So we want to set to a new vector2 with a random.range from, I don't know, 0 to 1 is going to be fine here. And random.range from 0 to... Oh, we do have to specify that these are floats, because otherwise it's going to do the integer version. Like that. So take this whole thing and add noise offset.x, and then take this whole thing, add noise offset.y. There we go. So now it'll not always use the same, so you won't always get the same island that pops up every little place. I'm not getting any islands. But it's definitely still doing per line noise, isn't it? We're just moving. It is. Maybe we'll make the effect a little stronger. Full cast inside. Oh, yeah, you're right. Yeah, it does have to be inside there. Thank you. Ooh, okay. Maybe. Although, I guess the, if we want, like, this is, the noise scale is like the islandiness. Larger values makes more islands. And lakes, I guess. It's not bad. It's not bad, huh? I don't know why it likes to make these a little longer. I don't know why the noise is turning out sort of stretched, it feels like, you know? It's not always. Oh, funny island chains. Is it because our map's not square? That's exactly what it is. It's because the per-line noise map is square. Our map is stretched to be twice as wide as it is long. As a result, it's stretching all the islands that way. I mean, this looks a little weird, but that would actually solve that. And we still have a math error on one of the diagonals. Because we should really be looking at... Oh, wow, that the selection is... Like, that square that's highlighted there and is about to go away. That's how we should be treating our per-line map, and we should just be using a portion of it. which this would do. This would always be using the top half of our map. It's a little weird. Vert scale fixer. Fix because our map is rectangular, but the Perline map is square. Mathmax. That's probably the best way of doing it. Yes, I agree. Totally. Groovy. Love it. mathf.max of, so use the biggest of num columns or num rows and do exactly the same thing on the other side. There. Love it. Thanks. Got a tip in. Who dat? Essie! 40 months! Yeah, you have been around forever. Still remember your name from our Darkest Dungeon run. That's crazy! There are probably viewers younger than that. Okay, yeah, that's really making me feel old. Also, Quill Creates inspired me to make a Stellaris War names mod. Oh, cool! On the other end of the scale, but still, no, modding is how a lot of people get started. That's fantastic. Oh, congrats. Let us know when it's out. I like this map. Now, one of the things is I did arbitrarily choose the distance for our continent spacing, but I think what would make a lot more sense is if we did something like num columns divided by num continents, right? So that should be the spacing between our continents should be based on how many columns we've got. So if I did 3, now they'd still be spaced 20 apart because I think we've got 60 columns. Might be wrong about, yeah, 30 by 60. Now we get 3 continent chunks. Oh my god! Look how great that map looks! So sexy. Wish I knew what that seed was. So I could just like save it for awesome. Okay, so that's one thing. Let's go then and take the next step, which is we want to be able to see our hills and mountains. So update hex visuals is responsible for setting things based on elevation. So what we want over here is we're going to want some tunable values for something like public float height mountain. So something like, I don't know, we'll see. So something like 8.5. So tiles with height above whatever is a whatever. Height hill is 0.6. And I guess we still want height flat, because this is how we can tune the sea level, right? It's like height sea level kind of thing. So way down here, what we do is bigger than or equal to height mountain. Else height hill, height flat. So we were just setting material. We'll still just set material for now because we don't actually have different models. I guess we don't actually have a model for for hills either. That's part of it. Tell you what, let's use grassland and then plains over here for the flat. So grasslands is going to be our hills, which isn't necessarily accurate right now, but just for the sake of our visuals, we'll have to do the models next, because that's really where the power thing is going to come in. Oh shit! Okay, we do have to tune our mountain code a little bit. First of all, I suspect very strongly that we have plenty of heights that go above 1, and we probably don't want to do that. We'll have to figure out some sort of way to make sure that like we don't get all these flat mountaintop insanities. Or we just say, listen, only when your height actually goes above 1 do you become a mountain. I suspect there's still going to be too much of that. So mountain. Yeah, it's because of that. It's because we're getting all these are ending up above 1. And so it's like, do we actually want to like multiply? Do we want to do something like that instead? Instead of just adding all the time from different values, we might want to do some multiplication. One interesting question might be for the Perline noise if, would we want to do this? No, we wouldn't want to do this. We'd want to do this. So right now this would technically put mountains right in the middle. Let's put one little mountain right in the middle of all this, which may or may not be what we want. Make things a little less noisy. All right, and then the add, that's the other thing. Elevate area adds. Let's just set. That's going to be a lot better because the overlapping was looking kind of cool, but there we go. Okay, it's starting to be a little bit more sane. 1.5. We don't want the Perline noise to make mountains by itself. It's like so tunable. There's like so many levers we can pull. Kind of like the noisiness that we had, I think, here. Or is it here? That's pretty good. I'm wondering, what if we don't want to lerp? What if we want to slurp instead? Do you not have... Do you not do slurping in here? Oh, I thought it would slurp. Or something else, like, or I guess we could do a power function here. Fall off more or fall off less? Maybe we want to do a square. So smooth things out a little bit. Square root. Because we're dealing with values below 0, so some of your assumptions are going to be a bit inverted. So if we should do this, I think we'll get more mountain. Sort of a flatter top. Or no, we get peaks. Right. Yes, we would get more peaks, which isn't quite what I want. Power. And then I just want to bring this down just a scooch. Okay, I'm going to stop effing with this, because at a certain point, it becomes just, you know, cosmetic levers you can pull, and that's not the point of what we're doing. But I'm pretty happy with the current state. We got nice little sexy lake over here, a couple of mountains with some hills in between, nice flat areas down here as we get closer to the water, but still some hills not that far away. Like, literally here, there's a hill on the coast, and here too. Love it. So you get, like, cliffs, right? Inland lake over there. Another little inland lake there, there. You know, this one happened to be kind of a straight line, but that's more of a fluke than anything. It's probably more of a side effect of our little hexes sort of lining up a little bit. All right, it's groovy. Coastlines are pretty bad now. Yeah, I guess the coastlines are a little too regular, huh? So we can break that up again here. There we go. We get our islands back as well. What if we bring it all the way back up to a 2? Feels a little too random. Or is it? I gotta say, like, it feels a little random here, but if you're thinking about Civ and you sort of come down here, that's not an unreasonable map. This is kind of Civ-like. Now, a lot of the Civ maps will do a little bit more. They'll simulate tectonics and erosion again. That's another way you could totally do it, right? Like, render down a fault line, make mountains along there, then erode it by just spreading out from there, and you end up with something that's probably a little bit more realistic, and yet I would play on this map. I would play Civ on this map. Maybe a few too many lakes, but I'm right with this. Yeah, I dig it. Okay. All right, next step. Well, what I'm going to do is I'm going to reset ourselves to a fixed seed over here, so we always get the same value. So this is going to be our map for testing. I like it. So every time we hit play, it's going to generate the exact same map for us because we're seeding the random system like that. By the way, if you don't know, there's no such thing as a random number on computers. Well, that's not literally true. Well, unless you got some sort of thing that's like measuring ambient background radiation and using that to seed something. Computers are really good at counting. They can't just pick something at random. They just count things. So random number generators on a computer are pseudo-random. They actually like process things through a sort of an equation that makes it so that you can't normally predict, right? It's going to go like pick a number from 1 to 10. So it's going to be like 2, 7, 3, 4. Like, and you don't know what the next one's going to be. You're like, I have no idea. Oh, it was a 9. Okay, you can't predict it. However, if you start with the same initial seed, you get exactly the same sequence every time. So it'll always go 2, 8, 3, 4, or whatever I said last time. It'll always go the same sequence if it starts the same seed. What normally happens when you start a program is it seeds the random number generator with like the current number of milliseconds since January 1st, 1970, or something like that. So unless two people hit play on their computer at exactly the same millisecond, there's really no way to do it. And every time you roll a random number, it progresses further down the sequence. So if you make a decision in a slightly different order than someone else, you'd end up with a completely different random number. So for all intents and purposes, there are random numbers. But the cool thing is, if you seed it with a forced fixed number like 0, instead of just number of milliseconds since, January 1st, 1970, then you always get the same result every single time. You couldn't predict what that result is without knowing the specific algorithm in the background, but you'll end up with the same amount. So that's fun. All right. What am I doing next? I guess units and stuff. You know what? We've been going for 2 hours. I think I'm going to stretch my legs, go pee. You should do the same. Get yourself a fresh beverage. And when we come back, I think we'll put down some units. The other thing we might want to do is make this work properly for wrapping. Which is an interesting question. Because this means the hexes we need to know the width of the world. We'll take a look at it. Short break. Be back in a couple of minutes. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cakefiend, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so, so much.